Hello, today we are working on lesson 3.2. So we are going to be exploring division of fractions with unlike denominators. So that means today we're going to work on dividing two fractions and they are not going to have the same denominator. We're going to look at a couple different strategies here and then you can choose the one that you like to do your homework with. So go ahead, if you have not already, and try out the Spark and show me a model of how you might solve the problem, and then come back and see how I would think about it. So we've got Rosalind is making stir fry. A recipe calls for 4 cups of broccoli, but Rosalind only has a 2/3 cup measure. How many cups of broccoli should she add when she's using her 2/3 cup? So I'm going to start and I'm going to draw what she has. And I know she has 4 cups here. And that one got a little too big here. So let me try that again. Oh, okay. So there's 3 cups. I'm making these as close to the same size as I can. So I know drawing with a mouse is not easy. So there is 4 cups. So 1 cup, 2 cups, 3 cups, 4 cups. And she is going to use 2/3 in all of these. So I'm going to use my unit fraction here and split my cups into thirds. So each cup I'm going to split into 1/3, 2/3, 3/3. So using that unit fraction is going to help me with the 2/3. So I've gone ahead and cut all of my cups into thirds. So I'm going to get a different color here. So now I'm going to scoop out 2/3 of a cup. So that means these 2 cups are going to go together. So here is 1. And then this cup needs to match with this one. So I'm going to keep some tallies over here. So then these 2 go together. So there's 2 scoops I need to make. And now I'm scooping out another 2/3 cup. So these go together. There's 3. Scoop out again. Here is 4 cups. 4 scoops, I should say, of 2/3. And then I scoop out 1/3 onto the next cup, 2/3. So those go together. So there's 5. And then I finish with my last 2/3. So it looks like I need 6 scoops to scoop all of the broccoli. So 6 scoops. So what if I had to add 3 cups of summer squash? I want you to think about that. If you need to draw another picture, you're welcome to. And so if you had to add 3 cups of summer squash, but you only have that 2/3 measuring cup, how much would you add? So go ahead and think about that if you have not done that already. Okay, so we're going to go on to task 1. So make sure you're on Ed with me. So we are going to think about this problem before we even look at any of the answers. So Rosalind also needs to add 5/8 cups of orange juice to make a sauce for her stir fry. If she uses a 1/4 cup measuring cup, how many measuring cups will she need to add? So one thing I would like you to do is open up in your Ed. So come to your main page and go to your Discover tab and look for your digital toolbox. Yours might be in a different place on the page, but it's under the Discover tab. Go to your digital toolbox. Scroll down and find the fractions and open up your fraction toolbar. You guys always have these tools available to you. So I know that she has 5/8 of a cup. So I'm going to go ahead and add 5/8 here and line them up. So go ahead and do that on yours. Okay, so we both should have 5/8 here. Now she only has a 1/4 cup measuring spoon though. So, or cup there. So I'm going to say I can notice when she scoops out a fourth, she's really getting 2/8 there. So if she scoops out another fourth, she scooped up 2/8. If she scoops out another fourth, she's only going to fill it up halfway. So these tools are here for you to use and think about whenever you need them. So let's come back to our problem here. So I know that she is scooping up 5/8 and she's using a 1/4 measuring cup. I can also think about that mathematically and turn my 1/4 into an equivalent fraction out of 8. So 4 goes into 8 2 times. So 1 times 2 is 2. So that means every time she's scooping out a fourth, she's getting 2/8, which we proved over here as well. Every time she scooped out 1/4, that was 2/8. So using that information, we're going to go ahead and complete tasks A through D on number 1 here. So back to our task page. So we're going to turn 1/4 into that equivalent fraction of 2/8. So we can divide 5/8 into groups of, what are we wanting to do? 2/8, sorry. I got distracted there. So every time we scoop out a fourth, we're really doing 2/8. So we're going to divide our 5/8 into groups of 2/8, 2/8, 2/8 as much as we can. So now we're going to use this number line and go ahead. And I notice it's cut into 1, 2, 3, 4, 5, 6, 7, 8 pieces. We've got 5/8. So go ahead and mark where 5/8 is. 1, 2, 3, 4, 5. So this is how much I have. So then using a different color, go ahead and circle groups of fourths or 2/8 because those are equivalent. So circle or block off 2/8, 2/8, and see what is left over. Just keep going all the way through 2/8. So then that should help you picture how much orange juice, how many cups as she scoops out that she needs to add. And you also have that fraction picture here as well. So it looks like she needs to scoop out 1, 2, and a half here. Okay, so then D, if she only used a 1/8 measuring cup, so every time she did 1/8, 1/8, and she still needs 5/8 of those, how many times will she have to scoop 1/8 out to get to 5/8? So if you need to use that fraction or draw yourself a picture, so she has 5/8, how many times will she have to scoop out 1/8? So first she had a 1/4, but then she found a 1/8. So what if she had a 3/8 measuring cup? How many times would she need to scoop that out? So think about your 5/8, block out 3/8, and see what's left over to see how many times she would have to use a 3/8 measuring cup. Okay, so we are going to fill in this chart of her results. So the first time she had 5/8, and we divided it into groups of 1/4. 5 divided by 1 is 5. 8 divided by 4 is 2. 2 goes into 5 2 times with 1/2 left over. 2 and a half, which is what we found up here. 5 divided by 1 is 5. 8 divided by 8 is 1. 5 divided by 1 is 5 whole times. So see if you can figure out this problem here and match it up. So I know the first one was 5. So it's got to be one of these two answers. So decide which one will this last part be here. Okay, so when I look at this problem, I noticed 5 divided by 3 does not work out very nicely. Kind of end up with a weird problem there. So I really like to use this strategy of using a reciprocal. So let's take a closer look at reciprocals here. So two numbers whose product is 1 are reciprocals. You might also hear it called the multiplicative inverse. And you'll see why we call it multiplicative in just a second. So reciprocal means opposite. So the opposite of 3/4 is to make it 4/3. I just flipped this fraction upside down. And I need to make it be a product, which means I multiply. So when I multiply here, let's see what happens. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. So the answer is 1. The answer to a multiplication problem is 1. So when you multiply something by its opposite, you get 1. So let's try this 5/8 here. So what's the reciprocal of 5/8? Is 8/5. And we're going to multiply. So I'm going to show you a little trick here. We can simplify going across as long as you have a numerator and a denominator. I see 5 and 5 are the same. 5 divided by 5 is 1 and 1. And 8 divided by 8 is 1 and 1. So we're just making our work a little easier here. 1 times 1 is 1. 1 times 1 is 1. 1 divided by 1, 1. So let's take a look at when we would use this. So some of those problems when we were dividing worked out great. 5 divided by 1 is 5. 8 divided by 8 is 1. 5 divided by 1, 5. And everything worked out perfect. They were all nice whole numbers when we divided. 3 divided by 9, though, is 3/9 or 1/3. That didn't end up in a nice whole number. 8 divided by 4 is 2, but I can't have 1/3 over 2. I can't have a fraction on top of a fraction. That just doesn't work. So that's where our multiplicative inverse or the reciprocal is going to come in handy. So we take our dividend, what we have. So I have 3/8 and we copy that one. That's what I have and I keep it the same. I'm not changing that. But we're going to multiply by the reciprocal. So instead of dividing, I'm doing the opposite of divide, which is multiply. There's my dot. And then I'm doing the reciprocal. Since I changed to the opposite of division, I have to change to the opposite fraction, which turns into 4/9. Now, if I look here, I can simplify. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. I also noticed that 4 and 8 are divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So I end up with 1 times 1 is 1. 2 times 3 is 6. So if I have 3/8 and I need to cut it up into 9/4, each part would be 1/6. So I can do that without simplifying first. It just makes a little more work. So 3 times 4 is 12. 8 times 9 is 72. And then I'd have to simplify, which turns into 1/6. So I like to do my simplifying first, so I'm not working with such big numbers. So let's go ahead and try parts E through D on task 1. So remember, we're going to copy the first one, keep it the same, change it to multiply, and flop and use the reciprocal of that second fraction. So let's take a look here. So first, see if you can find the reciprocals of each of those numbers. So flip them upside down. Hey, now we're going to use that copy.flop strategy there to find our products. So we had 1/4 here, so we need to flip that upside down. So it'd be 4/1. So see if you can finish and flip all of these fractions, and in order, tell me what each of the new numerators would be there. So filling in these question marks in a row. Hey, so then you're telling me this strategy. So using that copy dot flop method, so multiply the first fraction by the reciprocal of the second. So keep the first one, copy it, multiply, and flop. In each row of the table, the quotient is less than, is greater than, is equal to the, let's see, so the quotient here is the answer to a division problem, and we're comparing it to the product, 5 over 2, 5 over 2, 5, 5. So it looks like either way we do the problem, we end up with equal answers here. So in each row of the table, the quotient is equal to the product. So whether we divide or times by the reciprocal, that's the same process. We're getting the same answer. Okay, so let's go ahead and move on to task 2 here. So we've got this ribbon that they are cutting. Eric and Tom are making small bows for presents. They will need pieces of ribbon like the one shown, which is 2/9 long, which will be cut from a ribbon that is 3/4 of a yard long. So that's what they have. They have 3/4, and they're cutting it into 2/9. They used each a different method to figure out how many pieces they could cut. So let's take a look here. So Eric had 3/4, and he divided it by 2/9. And he changed that. Oh, I can see here, he used the copy dot flop method. So 3/4, so he times by the reciprocal. Times, he flipped 2/9 to make it 9 over 2. 3 times 9 is 27. 4 times 2 is 8. 8 goes into 27. 8, 16, 24, 3 times. There's from 24 to 27, 3 left out of 8. So Eric used this copy dot flop method. That's the method I prefer. So I like Eric's method. So let's check out Tom's here. So they set up their problems the same. They have 3/4. They're dividing by 2/9. So I'm seeing here 3 divided by 2 is not a number that works out very nicely. And 4 divided by 9 is not a number that works out very nicely. So he made common denominators here. So he found their least common multiple, which is 36. 4 to get to 36 is times by 9. 3 times 9, 27. 9 to get to 36 is times by 4. 2 times 4 is 8. So these bottom numbers cancel out. 36 divided by 36 is 1. So that's gone now. So 27 divided by 8 is not a great number, but it makes a fraction, 27 out of 8, which is what we ended up here. So then it goes in there 3 times and 3/8 left over. So if you like Tom's method of making common denominators and canceling out the denominators to make a new problem, that's great. You can use that. So you can choose either way that you like. So here, you're going to tell me the best thing that describes Eric's solution. So think about what did Eric do and see if you can find that answer here. Hey, now I want you to explain to me what did Tom do. So tell me this first part, what is 3/4 divided by 2/9? Where did that come from? Where did this second part come from? Where did this come from? So each step, just tell me step by step, what did he do to solve that problem? Okay, you're welcome to check and look at this sample answer, but please don't just copy it. I would love for you to do some thinking by yourself. That's how you're going to learn best. So now it wants to know how many whole pieces. So the quotient, the whole number, how many ribbons could be cut. And now this wants to know what expression tells us how much is left over. So if I come up here, I can see that they have 3/8 left over. But what I really have is 3/8 of 2/9. And that word of means to multiply. 3/8 of 2/9. We're going to multiply 3/8 times 2/9 here. He doesn't just have 3/8 left over. He's got 3/8 of the 2/9 ribbon, which means he only has 1/12 left. So what does 3/8 in the quotient mean? The amount of ribbon left over is 1/12, which is 3/8 of 2/9. So 2/9 is kind of like our piece there. That's what we want, and we only had 3/8 of it, which is 1/12. So when you have 3/8 of something else, we want to multiply to find that answer. Okay, so down here, just go ahead and tell me whose method you prefer, Eric or Tom's, and tell me why you like that way better. Let's go ahead and pause and do that. Hey, now we're on to task 3 here. So before we get started on this, I just want to remind you that the dividend is the total, or it's what you have. And it has to go first in our expression. So if we have Kyla is putting 4/9 of a pound of brownies on each plate, so this is what she's doing. She has 6 pans. This is our total. How many plates can she fill? So we're going to write an expression. That means just a situation to show what is happening. It does not have an equal sign when you write an expression. So she has 6 pans, and we're cutting it into groups of 4/9. Now, if I want to make 6 a fraction, remember we put whole numbers over 1. 6 divided by 1 is still 6. So then I would use this expression to solve that problem. So let's go ahead and look at task 3 now. So Tina feeds her dogs 4/7 pound of dog food per day. If she buys a bag containing 9 pounds of dog food, how many days will it last? So first we want to think about what does she have? What is the total she has? And we're going to divide it by the pieces that she's using every day. Let's go ahead and see which expression best represents this problem here. Okay, so now we're going to take that whole number 9 and write it as a fraction. So think back what we did here and how you make a whole number a fraction. So complete the sentence that describes what you need to do to find the quotient. So we're dividing by 4/7, so we want to find the reciprocal of 4/7, which is what? And then since we did the opposite of 4/7, we have to do the opposite of divide, which is what? So now show me which sentence is going to correctly show us what problem did we start with. Then use the copy dot flop. So which one here in the middle shows me copy dot flop correctly? Which one shows me the correct answer and simplified? So look through. So we're taking 9, dividing it by 4/7. Then we want to copy dot flop. So which one shows copy dot flop? And then which one shows the correct multiplying across? So then tell me the answer here of how many days the bag of food is going to last. Okay, so then I want you to think if that's how many days it took, so you just had that answer, think about how many pounds will they need for an entire year, remembering that a year is 365 days. So see if you can think about that and see about how many bags of food is she going to need to buy to last for an entire year. Okay, that is everything for our tasks today. So you'll go ahead and complete your check for understanding when your tasks are all finished. So let me know if there's anything I can do to help you with those.